Hello, let's continue our Sudoku adventure with 6-shooter by DJV. So we have normal irregular 6x6 rules. So what does that mean? That means that in every row, in every column, and every bolded region, we are placing the digits 1 to 6 exactly once each. So instead of having the normal 2x3 boxes, we have these bolded regions instead. There are still 6 of them, and they are still containing the digits 1 through 6. So think of them like boxes. They're just weird shaped. They're irregular shapes. That's why it's called irregular. All right. In addition to that, we have arrows. These are standard arrows. So there's arrows in the grid with an attached circle. Whatever the sum is of the arrow, that's filled in the circle. So if this was 1, 2, and 1, that adds to 4. This would be a 4. So that is how arrows work, and that is all the rules. So there's a link in the description if you'd like to try the puzzle yourself, and I am going to get started right now. All right, so there's a couple things I want to look at. First is this digit. This is sort of irregular geometry, which I think is always good to sort of look at to get to figure out more about the puzzle. This cell here needs to go in this row somewhere, and it can't repeat in its region. So it has to go here. So I'm marking them both purple to designate that they're the same digit as each other. Now this one here needs to go in this region. It can't repeat in the column and it can't repeat in the row. So it actually goes on this circle as well. These two purples look down into this region. That places a purple here. I'm guessing this region puts it on the circle as well. Yes, it does. And then this region puts it in this circle. All right, so all of these circles are the same digit. Given the title, I'm thinking it's 6, but we have to prove that. We can't just fill 6. But the next thing I was going to look at is this confluence of arrows here. A common trick is to combine arrows together and then try to minimize them. So let's think about what that would mean. So in this row, 1, 2 would be the minimum. That adds to 3. In this row, we could normally do 1, 2, 3, but there's a 3 in the rows. We'd have to do 1, 2, 4. That adds to 7. And then this could be 1 minimum. So we've got 3 plus 7 is 10, plus 1 is 11. So technically the minimum sum of these arrows is 11. However, these are the same digit, which means they have to add to an even number. And so we have to round up to 12, which is the maximum. That does actually put 6 into all the purples, because this has to be 6 plus 6 to make 12. So these don't need to be purple anymore because they're just 6s. So now... okay, one of these needs to be a 4. These are minimums, by the way. And there is 1 degree of freedom. But before I do that, one of these needs to be a 4. And this can't be the 4. Because it's a 1, 2, 4 triple. Actually, you can place a 5. But anyway, it's a 1, 2, 4 triple. One of them has to be a 4. This can't be a 4 because 4 plus 3 is 7. So one of these is a 4. So we'd have to do 4 plus 1 plus 1 to make 6. So these can't be 2 at all. This is the 2. This is the 1. So we have 6 here and then 2. So these need to add to 4. And the only way to do that is 1 plus 3. And that's our 1 degree of freedom that I was talking about. But we didn't even need to think about it. It just worked out. So there we go. That's cool. We got a bunch of digits. This can't be 1, 2, or 3. In fact, the row needs 4, 5, 6. And this sees a 5, 6. So that's a 4. That's a 5. That's a... Oops. Sorry, I was wrong. The row does not need 4, 5, 6. The row needs 2, 4, 5, which is a little bit different. So let's just fill that. It doesn't resolve. Okay, this is something I'm seeing. This is an X-wing, actually, but it's probably pretty easy to see the logic of it. This is a 1, 3 pair, and this is a 1, 4 pair. So both of these need a 1. So for the rows, the 1s are here, right? So there are 2 1s in these cells that I've highlighted in green. There are exactly 2 1s in these green cells. So what about these columns? Well, these columns also have 2 1s in total, and they're all used up by the green cells. They completely cover the green cells. So none of these can be 1s. We already knew these couldn't be 1s, but look, these can't be 1s either. And so this one looks down into the region. That places a 1 here. I'm sure that wasn't needed, but I saw it, so I figured I'd use it. These are both 2 minimum. I guess this is going to be a 1, 2, 3. Oh, this is 3 minimum. That's even better. Where's the 2 coming from? Is it bad that I don't see where the 2's coming from? Oh, from the region here. Oh, right. Yeah, it actually just has to be a 3 for the region. Whoops, my bad. And so 3 plus 1 is 4. That's a 2. That is a case where the red mark kind of told me about something that maybe I should have found myself, but that's okay. So what else is there to fill? We haven't looked at these 6s yet. There could also just be Sudoku to do. I need 3, 4, 5 here. So this is, okay. This can't be 1 or 2, so it's minimum 3, which means this is maximum 3, which means they're both 3. And that resolves these. Okay. This is resolved. It's a 5 for the column. All right, what next? This is a pair. We need a 2 and we need a 4. Not resolved. This is a pair. We need a 4 and a 5. Not resolved. Okay. We need 2, 3, 4 here. Okay, so the 3 in this column goes here. How are we doing on 3s? 3s are done. 2s are not done. 1s maybe. Okay, so 1s are here and here. And actually that does tell us that 5s are here. And this can't be 5 because there's a 5 in the region way up here. So one of these is 1, and it has to go with a 5, but it can't be this one because then we'd repeat 5 in the region. So this is 1, 5. Places the 4, places this one. 1s are done. Places the 5. So this is filled, and that'll give us the other one. That's a 2 with a 4. 2 and 4, 5. 2, 4, 4, 2, and 5, and we're done. Nice, 609. All right, well, thanks, DJV. That was pretty fun. I liked how these ended up resolving. We first did a global or a combination idea to get 6s into here. Actually, first we did geometry to prove that these two were the same digit as each other. That forced this to be even, so it couldn't be 11. It had to be 12. That filled 6 into all of these cells. And then in order to actually resolve the number, the individual arrows, we were forced to resolve them in a very specific way. So that was a really cool idea. Good use of irregular geometry. I'm sure this X-wing wasn't needed, but I liked it anyway. It placed this one, if I recall. So we had this one, and then these two ones looked in. So yeah, very cool. Thanks, DJV. I hope you all enjoyed this puzzle. And if you did, then why not leave a like, subscribe, and a kind comment below.